A very good morning, dear learners. I'm Dr. Divya Sharma. Welcome to the live session of Statistics for Management. Let me share my screen. Just give me a minute. Yes, I hope my screen is visible. Okay, perfectly fine. So let us start our session. So we are going to cover the first module today, that is Introduction to Statistics. And at the end of this session, you will be able to understand meaning, functions, and limitations of statistics, the concept of measures of central tendency, and measures of dispersion. So before starting any discussion, I want to ask from all of you, what comes to your mind when you hear the word statistics? So just give me some relevant words, whatever is coming to your mind when you hear this word statistics. Data, perfectly fine, okay. What about other? Summary, numbers, comparison, perfectly fine. Analysis, formula, okay. Numbers and data, accounts, okay. Information, graphs and numbers, collection of data, mean, median, mode, numerical data. So we are getting so many words here. Analysis, okay. Quantitative data, perfectly fine. Collection, calculation, research, prediction, okay. Probability, analysis of data, perfectly fine. Information expressed in numbers, financial data, okay. Mathematics, fine. Assumptions, forecasting, visualization, okay. Data trend, perfectly fine. So we got so many answers here in the chat box, and I can see one common word here, which is data. So actually, when we talk about statistics, the first word that comes to our mind is always data, right? So yes, it is a very relevant word, data. Now, it can be collection of data. It can be presentation of data, analysis of data. Then it can be interpretation of that data. What conclusion can you draw from it? So that means when we talk about statistics, it is actually collection, presentation, analysis, and interpretation of data. My screen is not visible. Some of the learners are saying screen is not visible. Let me know, is my screen visible? Visible, okay. So you need to check your connection. There must be some glitch from your end. As such, the screen is visible. Perfectly fine. I got your answers. Thank you. So when we say statistics, it may be defined as collection of data, presentation of data, analysis, and interpretation. So the whole procedure comes under statistics, right? Now let us first understand, what do we mean by data? When we say data, it can be segregated into certain types. What type of data are we talking about, right? So data, when we are collecting, it can be primary, it can be secondary. I hope you all know about primary and secondary data. Let us discuss about that. So what do you understand by primary data? First, let me know. Quickly, let me know, because I want to start the numericals also. So what do you understand by primary data? Raw data, well said, very good. Rough data, okay. Raw data, perfectly fine. So raw data as in the first-hand information, the data which you are collecting for your own purpose, right? So you know your area of interest, area of research, you know what is the purpose of collecting that data, how to do that. So therefore, you are collecting that data on your own. So that means the first-hand information. Secondary data, very well said, Gayatri. So data which was earlier collected by some other person, and you have collected, you are just using that data for your own purpose. That is secondary data, right? So this is the major difference between primary and secondary data. So we cannot say primary is better or secondary is better. Both have their own advantages and disadvantages. When we say primary, of course, that will be more reliable, because you are collecting that data on your own. That is collected afresh. When it comes to secondary, it was collected by some other person. So you don't know what was the motive of that person, whether there was some biasness or not, right? So there must be reliability issues with secondary data. But it is not always feasible to collect the data on your own, to have primary data, because it needs a lot of time, money, and efforts. When it comes to secondary data, it is easily available, so it requires lesser time, money, and effort. So we cannot say which one is better. Both have their advantages and disadvantages. It just depends upon our interest, our requirement, that which data we require. Now, when we say statistics, see, it is being widely used in almost every field. Whether you are interested in marketing or finance or entrepreneurship or let us say data sciences, anything, you require the basic knowledge of statistics. So it is widely used in almost every field, right? But when I say it has certain limitations as well. Now, what can be the limitations of statistics? You must have heard. Can you tell me any one limitation of statistics, whatever is coming to your mind? Limitation of statistics. We are saying it has a wide scope. It is widely used in almost every field. Accuracy. Very well said, Isha. So yes, not perfectly perfect. Well said. Yes. What about others? Inaccurate, insufficient data. Okay. Homogeneous, as in what is the problem with that analysis? Okay. Accuracy error. Assumption. Perfectly fine. Insufficient data. Very good. Deals with aggregate. Well said. So first of all, we can say that statistics never deal with individual figures. Okay. If I'm just giving you one numerical value, it is not statistics. But if I compare that value with some other data, right, there is certain comparison, there are certain numerical values, then we say that it is statistical data. So it does not deal with individual figures. It needs certain aggregate of figures or something, right? Then we can say that accuracy issue will always be there. We cannot expect 100% accuracy whenever we are dealing with statistical data. There must be certain errors or certain inaccuracies must be there. 100% precision, 100% accuracy cannot be achieved. Then one more very major drawback is statistical data deals with the quantitative data. It does not deal with qualitative data. So if you are giving some statement without some numerical values, then it may not be considered as statistical data. Okay, so it has certain advantages, it has certain disadvantages. A lot of theoretical portion is always there, is also there on the e-content, which you already have with you on your portal. I'm not moving my screen. It is just one slide I'm showing right now. I am going to move it now. Okay. So see, this is the live session and I am expecting that you have gone through the content that is already available with you on the portal, right? So please go through it. You have theoretical as well as numerical concepts in this subject. When we talk about the first module, the first unit, so you have theoretical concept as well, but numericals are also there. Now, as per my experience, I know a lot of students will face difficulties in numericals. So I want to discuss numericals now, right? Apart from these topics, if you have any other query, just let me know. I'll handle it at the end. So let us start now with the numerical portion. Go through the theoretical portion, which is available on your portal. If you have any doubt, please ask. You can use Ask Your Professor portal also to ask your doubts. Okay. Now let us start with the numerical portion. Now when we say numerical portion, the first thing that comes is measures of central tendency. So what are the three measures of central tendency? Tell me. Measures of central tendency. Mean, median, mode. Very good. That's the right answer. So mean, median, and mode are considered as the measures of central tendency. These are the values which represent the data. All the values are revolving around these values only, right? So when we say measures of central tendency, these are mean, median, and mode. Now let us discuss how to calculate these mean, median, and mode. And let me tell you, if you know how to calculate mean, median, and mode, your 80% work will be done, right? Whatever other topics you have in this module, those will be easily covered by you if you know how to calculate mean, median, and mode. Because all those tools are also dependent upon mean, median, and mode. So please pay attention here, right? take your pen and paper, solve the questions with me during the class, during the session. We have certain calculations. You can perform that later, but you should know how to calculate a particular column. So please be ready with your notebook and pen, right? When we say mean, median, and mode, see, your data can be ungrouped or it can be grouped. When we say ungrouped data, so if I have ungrouped data with me, let me write it here. Data can be ungrouped or it can be a grouped data. When we say ungrouped, that means some random values are given to us, right? So there is no proper grouping of that data, just random values are given to us. So how to calculate mean, median, and mode in that case? Whenever you are calculating mean means the average. You use this term very often in our day-to-day life also, right? So what is the average your car is giving? What is the average strength? And so on. So we use this term very frequently. So when it is ungrouped data, you have to just sum all the values divided by the total number of values. You will get the mean of that data. Okay. When it comes to median, you first have to arrange the data in ascending order. Check whether the number of terms are odd or even. If it is odd, you have to find n plus 1 upon 2th observation. If it is even, you have to find the average of n by 2th and n by 2th plus n by 2 plus 1th value. The average of these two values will give you the median. Okay. When it comes to mode, you can observe which is the highest occurring value in the data. That value will be mode. So for ungrouped data, it is very simple. Now, when it comes to grouped data, we further have segregations. It may be discrete or it may be continuous. When it is discrete data, that means some particular values are given to you and their frequency is given to you. So particular values as in some x, you will denote it by x. So let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the particular values. Their frequency will be given in the data. Frequency means what? Frequency means number of times the value is occurring in that data, right? So these two terms will be given to you in the question. So in order to find mean, median, and mode, you have formulas. So when you are finding mean, you may use either the direct method or the shortcut method. Okay. We will talk about both the methods when we go to continuous data. So there you can just have a look at the formula. Okay. When it comes to median, you first have to calculate the cumulative frequency. How to do that? We are going to discuss it when we do the numerical. And then you will find n plus 1 upon 2th observation, right? In front of that, what is the value of x? You will get median. When it comes to mode, the value whose frequency is the highest, that value will be mode, right? This is about discrete data. Now let us come to continuous data and we are going to solve some numericals also. So let me first tell you the formulas so that you can use them when we do the numerical. When we calculate mean, the first formula is direct method. Direct method is mean equals to sigma fx over sigma f. This sigma means summation, sum of values. Fx means frequency into column x. We are going to discuss how to calculate x, right? And then divided by sum of frequency. This is the formula of direct method when you have to calculate mean. Now comes the second formula, that is shortcut method. Shortcut method is also known as assumed mean method. Shortcut or assumed mean method. The formula says it is mean equals to A plus sigma FD over sigma F. A is the assumed mean, which we are going to assume, that we will discuss while doing the numerical. D means the deviation, that also we will discuss. Just have a look at the formula right now. And third one is step deviation method. Step deviation method. This says mean equals to A plus sigma FD dash over sigma F into H. Now, how to calculate D dash, what is H, we are going to discuss that. Now, I know that most of you will find the formula of direct method the simplest one, right? And of course, it is the simplest one. We are going to discuss what is A, what is D, what is D dash, everything we will discuss. So, but when we talk about the calculation, step deviation method is the simplest one. Okay, so if you ask me, I always prefer step deviation method just for the sake of calculation. As such, it depends upon you. It is your wish. Whichever method you want to use, you can use that, right? There is you will get the same answer if you use any of these three methods. If it is written in the question that you have to use this particular method, then you have to use that, right? As such, you will have the same answer by using any of these methods. So let us discuss about it now. Let us do one numerical question so that you have a better idea. So let me come to this question. Yes, so the question here says class intervals are given, frequency is given. You have to calculate mean, median, and mode. So let us do that. Let me first write class intervals here and frequency here. So class intervals are 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Frequency is given 6, 10, 16, 14, 10, 5, and 2. Now, just listen carefully. Whether you are using direct method or shortcut method or step deviation method, the first step is find X. What is this X? X is mid values of the class interval, right? So mid values of the class interval. How to calculate that? The first interval is 30 to 40. So how to calculate the mid value? Lower limit plus upper limit divided by 2. So 30 plus 40 is 70 divided by 2 will give you 35. Similarly, 40 to 50. 40 plus 50 is 90 divided by 2 will give you 45. Then you have 55. Very good. Yes, right answer. 65, 75, 85, and 95. So if you have a gap of 10 in the intervals, of course, there will be a gap of 10 units in the mid values as well, right? So this is X. So the first step is find column X. X means mid values of the class interval. Now, if you're using direct method, you will find F into X, right? If you're using shortcut or step deviation method, then you are going to have deviations. This is continuous data. Discrete is if you have particular values and their frequency. Here a range is given to you. So this is continuous data. So D is the deviation. How to calculate D? D is X minus A. I will repeat the formula. Don't worry about that. Just concentrate here how to find these columns. So you may have it here Fi, Xi, Di, that just denote D1, D2, D3, right? So in general, you can write D equal to X minus A. So D equal to X minus A, D are the deviations. So how to calculate D? See here, this A is assumed B. We have to assume any one value from the column X, not from F, from the column X. Now, there is no hard and fast rule that you have to just assume the middle value, nothing like that. You may assume the first, second, middle, last, whichever value you want to assume, right? At the end, your answer will be same. Of course, your column values will be different. So you can assume any value just for the sake of calculation. We try to take the middle value, right? But there is no rule that you have to take the middle value. You can assume any one value. So I have assumed 65 here. So let us take 65. This is A, assumed B. Now, what we have to do is just subtract this value of A from all the values of X. So what we have to do is 35 minus 65. This is not 30. This is minus 30. Do not ignore the negative sign. 45 minus 60, minus 20, minus 10. This is 0. Then we have 10, 20, and 30. So we have subtracted this assumed value, assumed mean, from all the values of X, right? Now, if you are using shortcut method, you will calculate F into D. That means you will multiply the corresponding values of the column F and the column D. If you are using step deviation method, we have to form one more column, which is D dash. D dash is D upon H. That means we are going to divide the deviations by height of the interval. H is height of the interval. So height of the interval, how to find that? The gap between the interval. So you can observe here the gap is of 10 units. Upper limit minus lower limit. So 30 to 40. 40 minus 30 will give you 10. 50 minus 40 is 10 and so on, right? So height of the interval is 10 here. So what we are going to do is, we are going to divide these deviations by 10. So we have minus 3, minus 2, minus 1, 0, 1, 2, 3. I will explain it again. Just pay attention. Then at the end, I'll again tell you what we have done. Okay. So this is D dash. The last column that comes is F into D dash. Now what we have to do? We have to multiply the corresponding values of the column F and the column D dash. Okay. So how to do that? 6 into minus 3. Do not ignore the negative sign. It is minus 18. 10 into minus 2, minus 20. Then we have minus 16. 14 into 0 is 0. Then we have 10, we have 10, and we have 6. This is column FD dash. D dash I have calculated by dividing deviation D by height of the interval. I will explain it again. Please pay attention. I will tell you what we have done. So now at the end, what I need is, I need to find the sum of the values of the column FD dash and sum of the values of the column F. So I have already calculated it. My FD dash, sum of FD dash is coming out to be minus 28 and sum of frequency is coming out to be 63. You can check it, right? Sum of FD dash is coming out to be minus 28 and sum of F is coming out to be 63. Okay. Now let me first explain what we have done till now and then we will apply the formula. Please pay attention. I'm repeating what we have done. Class intervals and frequency, these two things are given in the question. The first step whenever you are calculating mean is find X. X is mid values of the class interval. How to find mid values? You just have to add both the values of the class interval divided by 2. So lower limit plus upper limit divided by 2. So for the first interval, the mid value is 35. For the second interval, it is 45, then 55 and so on. These are X. Okay. Next step, because I am using step deviation method. So the next step is calculate D. D means deviations. How to do that? The formula of calculating D is X minus A. You have to assume any one value from the column X and subtract it from other values of the column X. So I have assumed here 65. You can assume any value from the column X. At the end, your answer will be same. You will get the same mean, but your column values will be different. Okay, I'm repeating what is X. X is mid values of the class interval. Right, so if I have 30 to 40 as my class interval, how to calculate the mid value? Just add 30 and 40. So 30 plus 40 is 70 divided by 2. That is 35. This is how you calculate mid value, no? So that is X. D is deviations. That is X minus A. You can assume 35, Aditya, no problem. If you have taken A equal to 35, that is perfectly fine. What will be your values then? In that case, 35 minus 35, the first value will be 0. Then you have 10, 20, 30, 40, 50 and 60. So take the values accordingly. I'm saying at the end, your mean will be same. Of course, these column values will be different. So you can assume any one value, okay? So these are the deviations. After deviations, we have calculated D dash. D dash is D upon H. That means deviations, which we have already calculated, divided by height of the interval. What is this height of the interval? Height of the interval is 10 because you have a gap of 10 units. So 30 to 40, that means 40 minus 30, that is 10. 50 minus 40 is 10 and so on. So H is height of the interval. A is the assumed mean, the value which we have assumed. We can assume any one value. I have taken here 65. So therefore, I have calculated D accordingly. You can assume any one value. Then comes D dash, which is D upon H. The last column, because I am using step deviation, is FD dash. So if you are using direct method, then you will calculate F into X. If you are using any other method, if you are using shortcut method, then you have to take f into d. If you are using step deviation, do f into d dash. I'm saying there is no hard and fast rule. You can assume any one value from the column X. Just for the sake of calculation, we try to take the middle value, because you can observe here, when I take some value, middle one, right? Like here I have taken 65. So I'm getting 0 here in front of 65. Above that, negative values are there. Below that, positive values are there. Similarly, when you are calculating d dash, your calculation gets simpler. Only that is the reason. As such, you can assume any one value, okay? So f d dash, we are calculating, that means we are multiplying the corresponding values of f into d dash. Okay. So in that case, 6 into minus 3 is minus 18, 10 into minus 2 is minus 20, and so on. After that, we have calculated the sum of the values of f d dash, which is minus 28, sum of the values of the frequency, which is 63. Till now, we have done this. Okay. Yes, if you have the intervals of this form, 30 to 39, 40 to 49, these are there also you have range, but you need to first convert it into exclusive type. That means you will subtract 0.5 from the lower limit and add 0.5 to the upper limit. Fine. Okay, let me now first complete this question, and then I will take your queries at the end. So f d dash, till here I think I'm clear. Now let me apply the formula of mean. So mean equals to, because I have used step deviation method, so it is a plus sigma f d dash over sigma f into h. A, the value which we have assumed, I had assumed 65. So I'm writing 65 here. If you have assumed some other value, please write that value here. If you had assumed some other values, your values of f d dash and all other values will be different. So please do that accordingly. So I have assumed 65. Accordingly, I'm telling you. So this is 65. Sigma f d dash is coming out to be minus 28. Sigma f was 63 into height of the interval is 10. So this is what you have to calculate. Yes, that's the right answer. So we have 65. This is minus 280 over 63. Just take the LCM, divide it. Your answer will be 60.55. Now there can be a difference of this second decimal place, but not more than that. It can be 60.56 if you're getting 55 and the third digit is some greater than 5, then you can round off the second digit. Otherwise, just leave it here, right? So this is 60.55 or 60.56, whatever you're getting. So this is the way of calculating mean. Yes, it is very easy. It is very simple. When we talk about statistics, of course, you have a lot of formulas with you, but it is easy to remember the formulas. And we just have one way of doing that. So you just need to pay attention to your calculation, do that very, with full concentration, and then do it carefully, and then just apply the formula, plug in the values there, you will have your answer. Okay. No, you cannot say it is 61. Do not round off the value. You can just round off the second decimal place. Fine. So this is the way of calculating mean. This was class interval. Now let us calculate median. So median is, now let me again write the class intervals and the frequency, and then we are going to calculate the median. Just give me a minute. Let me write the class intervals and frequency. So we have 30 to 40. H is height of the interval, upper limit minus lower limit. 30 to 40, 40 to 50, 50 to 60, up to 90 to 100 we have. 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Frequency is also given in the question. It is the same question. We were asked to find mean, median, and mode. So mean we have calculated. Now moving towards median. Let me write the frequency. So we have 6, 10, 16, 14, 10, 5, and 2. This is the question. Now we have to calculate median. How to calculate median? When we were calculating mean, the first step was we had to find X. Now in median, we do not require X. What we need is, we need cumulative frequency. We will talk about the formula of median. Have patience. So CF. CF is cumulative frequency. How to calculate cumulative frequency? Just have a look. The first value of the frequency will remain the same. So this is 6. right? Then we will keep on adding the consecutive values. So 6 plus 10, this gives me 16. 16 plus 16, that is 32. Plus 14, 46. Plus 10, 56. Plus 5, 61. Plus 2, 63. Right? What we have done? The first value of the frequency remains same in CF. So the first value is 6. Then keep on adding the consecutive values. So 6 plus 10, that gives me 16. 16 plus 16, 32. Plus 14, 46. Plus 10, 56. Plus 5, 61. And plus 2 is 63. This is the way to calculate cumulative frequency, right? Now, what you have to do is, you can observe that the last value of cumulative frequency is actually the sum of frequencies, right? That is what we have done. The last value of CF is denoted by N. So N here is 63. We need to calculate N by 2 because we are going to use this term in our formula. So this is 63 by 2, right? That gives me 31.5. This is not median. What we have to do now, we have to check the first bigger value, then this 31.5 in the column CF. Either the equal or the first bigger value. So equal value is not there. So what we are going to consider? The first bigger value, then 31.5 in the column CF. So the first bigger value here is 32. In front of that, this is my class interval. So this is my median class. Median class means the value of the median will lie in this range, 50 to 60. But the exact value I can figure out by using the formula. So the formula of median is L plus N by 2 minus C over F into H, where L is lower limit of the median class, N by 2 is the value that you have already found, C is cumulative frequency of the class preceding the median class, F is frequency of the median class, and H is height of the interval, right? So we just have to plug in the values now. Can you tell me what is the value of L here? Quickly write your answer in the chat box. What is L here? Very good. 50. Very good. Perfectly fine. So 50, that means lower limit of the median class. If you're getting confused, just wait. I'll explain everything again. Just pay attention. So L, that means lower limit of the median class. That is 50 here. Plus N by 2, we have already found. It is 31.5. Minus C is cumulative frequency of the class preceding the median class. Can you tell me what is C here? Very good. Perfectly fine. 16 is the right answer. I'm getting some different answers in the chat box. 16 is right. Listen carefully. C is cumulative frequency of the class preceding the median class. My median class is 50 to 60. The preceding class is 40 to 50. It's CF. So therefore it is 16. So I'm writing here 16. I will repeat again. Just have patience. Divided by frequency of the median class. What is F here? What is frequency of the median class? Very good. It is 16. So this number. So coincidentally in this question, you have C and F to be equal, but this is not the case in every question. So you should be well aware with the terms. So F is frequency of the median class. So frequency here is 16. Into height of the median class, that is 10. 60 minus 50 is 10. Perfectly fine. So you just have to calculate this. So you will have 50 plus 15.5 over 16 into 10. That will give you 50 plus 155 over 16. Take LCM and divide. You will have 59.68. 59.68. That is absolutely correct. Now let me repeat what we have done. Okay. Whenever we are dealing with continuous data, whether your n is odd or even, we used to consider n by 2 only because we need that term in the formula. And it will not create any difference whether you take n by 2 or n plus 1 by 2. So therefore, we always prefer to take n by 2. When it is discrete data, you always take n plus 1 by 2, right? This is the rule. Fine. Now I'm repeating what we have done. Some students were getting confused. Please pay attention. Listen carefully. We had to calculate median. Class intervals and frequency were already given in the question. Of course, it is grouped data. It is continuous data. So the first step in order to calculate median is find cumulative frequency. How to calculate cumulative frequency? We have to write the first value of the frequency to be similar. So we have written here 6, right? Then we keep on adding the consecutive terms. So 6 plus 10 is 16, plus 16 will give you 32, and so on. The last term is 63. I'm saying whether n is odd here or even, you need not to worry about that. You always take n by 2. That we have to check when it is ungrouped data. In that case, you have to check whether it is odd or even and then find the value accordingly. When it is a continuous data, you have a range with you, then you just have to consider n by 2 here. Now I'm repeating, please have patience. So the last term of CF is denoted by n. So n is 63, the last term of CF. We have to consider n by 2. N by 2 means 63 by 2, which is equal to 31.5. What we have to do is, we are not choosing the interval on our own. There is a rule of doing that. Listen carefully. N by 2 is 31.5. Please pay attention. This is not your median. This is a very common mistake that students used to make. They used to think that this is the median. This is not the median. 31.5, the value which you have obtained, you have to check either for the same value or the first bigger value than this value in the column CF. So the first bigger value than 31.5 is 32, right? In front of that, so let me first erase the highlighting so that you don't get confused. Now listen carefully. N by 2 is 63 by 2, which is 31.5. You have to check either the same value or the first bigger value than 31.5 in the column CF. So here we do not have the same value. So therefore we can consider the first bigger value. So the first bigger value than 31.5 in the column CF is 32. In front of that, this is my class interval. Therefore, I have obtained my median class. I am not selecting it on my own. The first bigger value than 31.5 is 32. In front of that, I have the interval 50 to 60. So therefore, this is my median class. That means my median will lie in between this range, but the exact value I can find only by applying the formula. So this is the formula of median, which says it is L plus N by 2 minus C over F into H. Okay. So L is lower limit of the median class, which is 50 here. This is the lower limit of the median class. N by 2 is the value which you have already found, which is 31.5. C is cumulative frequency of the class preceding the median class. So the class which is preceding the median class is 40 to 50. In front of that, this is the CF. So this is your C. How is 50? 50 is lower limit of the median class. L is lower limit of the median class, right? Listen carefully. We are not selecting 50 to 60 on our own. I'm saying you have to select the first bigger value, then 31.5 in the column CF. The first bigger value is 32. In front of that, this is your class interval. So why will you select some other interval when this is the class interval in front of it? So lower limit of the median class, that is 50. N by 2, 31.5. C is cumulative frequency of the class preceding the median class. So this is it. F is frequency of the median class. So this frequency, that is 16. H is height of the median class. So there is a gap of 10 units, 60 minus 50. So 10, height of the interval is 10. So you just have to solve this. You're getting 59.68. N is the last term of CF. That is denoted by N, this value, right? So this is median. I hope now it is clear to everybody. Let us quickly move to mode. Now, how to calculate mode? Just have a look. C is cumulative frequency of the class preceding the median class. This is the median class. The preceding class is this. This CF, that is 16. Okay. Let us quickly come to mode now. So when it comes to mode, let us again write the same question, class intervals and frequency. So it is again 30 to 40, 40 to 50. Let me write it properly, just a minute. Yeah. 30 to 40, 40 to 50, 50 to 60, up to so on, we have it 90 to 100. So 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Frequency again, we have 6, 10, 16, 14, 10, 5, and 2. Now it is very simple to calculate mode because you need not to find any new column now. What we require to do is we just have to check the highest frequency here. So can you tell me which is the highest frequency? 16, that is right. So here the highest frequency is 16. We are going to denote it by F1. The highest frequency will be denoted by F1. Now in front of the highest frequency, this is your class interval. So this is your modal class. We are not selecting it randomly. What we are doing is the highest frequency is 16, right? So therefore it is denoted by F1. In front of that, your class interval is 50 to 60. That is your modal class. Now I got the idea that the modal class is 50 to 60. That means my mode will lie in between 50 to 60. But what is the exact value? That you have to again check by using the formula. Now, what is the formula of mode? It is L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. So this is F2 into H, right? So here L is lower limit of the modal class. F1 is the highest frequency. F0 is the frequency preceding the highest frequency. Can you tell me the value of F0? I'm saying frequency preceding the highest frequency. Very good. It is 10. And F2 is the frequency succeeding the highest frequency. Can you tell me what is F2? Excellent. It is F2. 14. Right? So these are the notations, and H is again height of the modal class. So L is lower limit of the modal class. What is L here? What is L here? Tell me. Very good. It is 50. Lower limit of the modal class. So 50 plus we have written what is F1, F0 and F2. So this is 16 minus 10 over 2 into 16. That is 32. This is minus 10 minus 14 into height of the interval, height of the modal class, which is 10. So this is what you have to solve here. So after solving all this, your value will be 57.5. Absolutely correct. Very good. 57.5 is the right answer. So someone was asking if you have highest frequency at more than 1 point. Very relevant question. There may be questions when you have the highest frequency at more than 1 point, and that is called bimodal frequency. So in that case, we have a grouping method which we have to first apply, and then we move to the formula, right? You need not to worry about that. You need not to worry about the grouping method because in your syllabus it is not there, but of course you should know about it, right? So you can check grouping method, right? I will also share the link of the video where I'm explaining grouping method to you. As such, it is not in your syllabus, so you need not to worry about it. So in grouping method, we need to make a group of 2, 3 values, and then we proceed accordingly. Then we used to have one class interval, which is selected as the modal class, and then we apply our formula. Okay. Yeah, that is what I have told Rohan. If the highest frequency is at more than 1 point, that is the case of grouping method. That is bimodal frequency, right? So this is how you have to calculate mean, median, and mode. So these three concepts are very simple. What is F0? F0 is the frequency which is preceding the highest frequency. See here, the highest frequency here is 16. So the value of the frequency which is written just above it, that is your F0. And the value of the frequency which is just below it, that is your F2. Okay. So this is how we used to calculate mean, median, and mode. These are the three measures of central tendency. These are the basics, right, for the other tools as well. So you have measures of dispersion also that we need to do now. So if you know how to calculate mean, median, and mode, then it is very simple for you to calculate other tools as well. Okay. So now let me proceed to the next question quickly. Let us proceed to measures of dispersion. Now, what are measures of dispersion? When we say measures of central tendency, okay, just wait. I will handle your queries. Just give me 2 more minutes. Let me first just give you an idea about measures of dispersion. I think we will solve the numerical questions in the next session. So before proceeding to module 2, I will first give you 1 or 2 questions on measures of dispersion, and then we will proceed to to the next module in the next session. Fine. Okay. So when we say measures of dispersion, see, measures of central tendency, what is it all about? It is actually giving us the idea about the data. These are the values which are actually representing the data. We get an idea that all of the values are revolving around these values. Okay. When we say measures of dispersion, then what we are calculating that by what deviations are the other values have a gap with the measures of central tendency. Like, for example, in some cricket match, there is some player and the analysis has been done that what was his score in the last 5 matches, right? So his score was just obtained and they had obtained some x1, x2, x3, x4, x5, these 5 values of his last 5 matches. Now, for the other batsman also the same thing has been done, for the other batsman also the same thing, right? Now, what analysis is being done is what can be his worst and the best scores. So what they used to do is they used to find the average of his score. They used to calculate the standard deviation. Fine. So what they do is if the average, let us say, is some x units, then x minus the value of the standard deviation and x plus the value of the standard deviation can be his worst and the best scores. So therefore, they get an idea that which batsman should be sent first. Okay, so this is just an example of showing you, of telling you that what is the importance of these measures of dispersion. So we can just calculate his best and the worst score, and accordingly we can take the decision. So this is how analysis is being done, right? So when we say measures of dispersion, we are actually calculating that how far the other values are from the measures of central tendency. So when we say measures of dispersion, we basically have 4 tools. We have range, mean deviation, standard deviation, and quartile deviation. If you know how to calculate mean, median, and mode, these tools will be very simple for you to calculate, right? So when I say you have range, range means the largest observation minus the smallest observation. So whichever is the largest observation in your data, whichever is the smallest observation in your data, subtracting that, you will have the value of the range, right? So if I give you some discrete data, some ungrouped data, let me give you some example. 3, 10, 12, 1, 2, 5, 7. Can you tell me the range of this data? Quickly let me know. 11. Okay. What about others? 11. Perfectly fine. So we can see here the largest observation is 12. The smallest is 1. 12 minus 1 is 11. So 11 is the range here, right? If I have discrete data, I have X and F with me. So let me give you 3, 7, 10, 12, 15, 20. Frequencies, let us say 1, 2, 7, 5, 4, and 2. Can you tell me the range of this discrete data? Quickly let me know. What is the range? 17, 10. Yes, what about others? 17, okay. Others, I just got 3 answers. 17, okay. 17, 5, 17, 17, okay. So 17 is absolutely correct. Whenever you are finding range of a discrete data, you have to consider the values, not the frequency, right? The values are represented by the column X. So the highest one is 20, the lowest one is 3. 20 minus 3, which will give you 17. That is the range, right? If I give you continuous data, let us say I have, say 0 to 10, 10 to 20, 20 to 30, 30 to 40. And frequency, let us say 5, 3, 2, and 1. Can you tell me what is the range here? 40, okay, 4, okay, 40, perfectly fine, 4, 40, 40 and 4, 10 also, I got some different answers. 40 is absolutely correct. When you're finding range of a continuous data, what you have to do is the highest value here is 40. The lowest value here is 0. So 40 minus 0, that gives you 40. That is the range, right? So range is one of the tools of measures of dispersion. We are going to talk about other measures of dispersion in the next session now, because I want to give you a numerical to practice. So we will discuss about other three tools, okay? So let me quickly take your queries now, and then I think you can go through the content that is already available with you. So we are going to discuss about quartiles, quartile deviations, mean deviation, standard deviation, and everything. Fine. And then we will proceed to the next module in the next session. Okay. So that is all about today's session. Now let me quickly handle your queries. So yes, whatever doubts you have, now you may ask. So I can see answers. Yes, range. Median in ungrouped data, I've already explained. See what I have explained. Now you can go through its recording, right? And just check whatever we have discussed today. Whatever, apart from that, whatever doubt you have, please ask. Short, what are you asking? Shortcut method in finding F1 and F2? I didn't get your question. Mean, median, and mode, I've already discussed about it. Please go through the recording. Mode answer was 57.5. Yes, that's correct. See about examination, if you have any query, so yes, you will have inbuilt calculators there which you can use. You will have the option to insert the symbols, to insert the equation, so don't worry about that, and you still have time, so we will discuss about it later on. You will have your sessions, practice sessions for that. Okay, you can calculate mean by any of the methods. You will have the same answer at the end. This is the first session of statistics, Bindu. Don't worry about it, right? Please go through the recording if you have missed something. Still, if you have any doubt, please let me know. I'll definitely handle your query. N, when we use the formula n plus 1 by 2 in median, I told you when you have ungrouped data with you, right? So what you have to do is you have to arrange that data in ascending order. Check number of terms are odd or even. If it is even, it will be n by 2 and n by 2 plus 1, the average of these two observations. If it is odd, it will be n plus 1 upon 2th observation. Okay. Recording will be there because this is your first session today, right? So recording will be available after, let us say 2 to 3 hours. You will have that. You will have the recording, of course. I am telling you the maximum time of it. You can check it later. Why are we finding central measures of central tendency? I have explained it so many times in the class today. So when we say measures of central tendency, these are the values which are actually representing the data. Okay. So thank you so much. I think all your queries have been solved. So for further practice, if you need questions, please go through the content that is already available with you, right? Just go through all that. You can practice as many questions as you want. If you have any doubt, please let me know. I'll definitely handle your query. I'll definitely reply. About the formulas, you have to, of course, memorize the formulas. It is easy, not very difficult. At the end of our all 5 modules, I will share the compiled list of formulas with you. But at the end, right, after completing all 5 modules. Till then, please make your own list. Yes, this was module 1. So thank you so much, everyone. Hope to see you all in the next session. Practice questions, okay? Thank you.